Ratios. It's a comparison of two quantities by division. You can write a ratio in three different ways. Okay, so basically you're going to compare two different quantities. You will compare cats to dogs. You'll compare apples to oranges. You'll compare cupcakes to pencils. Whatever it is, they're going to be different quantities for the most part. Okay, you could compare, girls in 7th grade to girls in 8th grade. Still a different quantity. Okay, we can write them. We can write ratios in three ways. Okay, for example, if we're talking about the ratio 5 cats to 24 dogs. One of the ways in which we write a ratio is to separate them using a colon. The other way is to simply just use the word to. And finally, the third way, which is probably one of the more popular ways or more common, is to write it in fraction form. Does it automatically make it a fraction? Does it automatically make it a fraction if you put it in fraction form? No. Because you're comparing two different quantities. Okay, a fraction most of the time just compares or just is dealing with one value, one quantity. Okay, so when you simplify these, you'll have to make sure that you have two values remaining. We'll get to that, what that looks like and what that means. But any question as to how you write the ratios? So let's take a look at page 243. Pardon me? Yeah? Yeah, you can choose, but by and large, that way is still going to be the easiest for you. Unless they tell you specifically what way they want you to write it. So numbers 1 through 3, write a ratio in three ways, comparing the first quantity to the second. So here they're asking for all three ways. Number 1 says, a week has 5 school days and 2 weekend days. What's the ratio? Yes? 5 to 2. What's the other way I can write it? Give me another way I can write that same ratio. Yes? 5 over 2, and Mia said 5 to 2. Focus real quick on that ratio. At first glance, it looks like it's what? An improper fraction. And if it were an improper fraction, and you were told to simplify, your first instinct might be to convert it to what? One and a half? Okay, don't write this. You might say, oh, that's easy, that's 2.5. But a ratio compares two quantities. A 5 to a 2. What do I have here? I have a 2, a 1, and a 2. Am I still comparing two quantities? Not necessarily. So if it's even written as what we would normally call an improper fraction, you must keep it as an improper fraction. Do not simplify it into a mixed number, otherwise you take it out of being a ratio and into a fraction, which aren't necessarily the same thing. The order. Let's talk about the order. The order in which you decide you're going to write them. Like, okay, I'm going to put the colon first, I'm going to put the fraction second, and I'm going to use the word to last. Does that order matter? No. But the order of the digits themselves is 5:2 the same as 2:5. Not if I'm comparing weekdays to weekend days, which is what number 1 is doing. If I all of a sudden change it from 2 to 5, what am I saying? 2 weekdays to 5 weekend days. As much as we'd like that to be true, it's just not. I cannot change those digits, okay? So that doesn't work. Just like 2 to 5 doesn't work, okay? So the order of them has to be consistent. Look at number 2. Number 2, about 24 out of 25 Californians live in a metropolitan area. So, (24:25). Another way, Key. 24 over 25. And finally, Chris, 24:2. 25. Number 3, about 1 in every 4 people swims at least 6 times a year. Alex? One colon what? 1:4. 1 over 4. 1 to 4. Yes. Six times a year is what separates the 1 from the 4. If 1 out of every 1 to 4 people swims 6 times a year, how many people don't? Right. So it definitely makes a difference as to what you pick. So just, they're going to try to trick you at least a little bit, so you got to pay attention to what's going on. Number 4 through 7, express each ratio as a decimal. So the first ratio they give us is 7 to 8. Now, written this way might be a little bit deceiving. Is there another way I can write them from the choices I have that might make it a little bit easier to convert to a decimal? Chris? So let's write it this way. Now it looks like a fraction. I can treat it as such. How would I put 7 to 8 into a decimal? Leanne? Okay, I divide 7 by 8. Set it up. 8 into 70 is 8. 8 into 60 is 7. 8 into 40 is 5. The decimal there is 0.875. Number 5 says 18 to 5. Again, might not want to use that particular form. Is there a form I could use that'll make it a little bit easier? Which is it? Not 5 over 18. 18 over 5 as a decimal, I'm going to have to do this. Bottom value always goes on the outside. So 3, 30, decimal there, 3.6. Now, can you see why this one equaled that and this one equaled that? Does that make sense to you? 1 gives you a value that's less than 1 whole. This one gives you a value that's over 3. What does it mean? What does it all mean? Yeah. If this were an 8, 8 over 8 would equal 1 whole, right? But it's still smaller than what your bottom value is. The other thing is this. Give me a noun. Give me a noun, English people. Yes? Elephant. So 7 elephants. Give me another noun. Cheese? How about cheeseburgers? If I were to really, really, really try to simplify this ratio, I would say I would have 0.875 elephants for every 1 cheeseburger, right? That's what it's essentially saying. If I were to put that into a decimal, all right, it's almost 1-to-1, almost even, 7 to 8, almost even, not quite. Here, again, 18 to 5, if I said dogs to people, what am I really saying? 3.6 dogs per 1 person, okay? When I find out what the decimal is, that's really what I'm saying. Are there more than 3 times as many of one than the other? Sure there are, right? Exactly 3 times this amount would be 15. It's more than that. Yes? No, it's just an average. It just gives you an idea. Here, Africa, here is your ratio, 18 to 5. But if you're trying to find out what the relationship of one quantity is to the other, that's what it means. Right. For some things, it's hard to say 3.6 of, but you will be asked to simplify ratios from time to time. And again, you've got to be able to do so. So when you get something like this, 267 to 100, you're going to divide. Power of 10, how many zeros in 100? Move the decimal 2 places to the left. 2.67 to every 1. Are there more than twice as many here than there? Twice as many of 100 is 200. You have 267, that's more than twice as much. Just like here. It's more than a 2 to 1. In fact, it's almost a 3 to 1. What would this have to be to make the ratio exactly 3 to 1? Chris, 300. 12 to 25, find the fraction. Set it up as a fraction first, just because I think that that's easier. Now, if you look at it, just pay attention to what, this is all just kind of getting better with numbers and looking at numbers, being able to identify with what's going on. If this were a regular fraction that we were putting into a decimal, say this was an assignment that you had where you scored 12 out of a possible 25. You'd say, ouch, I scored less than what percent? Less than 50%, less than half. When you put this ratio into fraction form, the bottom value always goes on the outside. Here's my decimal. Now you get to work. It does not go into 12. I need to add a 0. 25 into 120. 4 is 100. 20 left. Drop the 0, Leanne, into 200. 8. My decimal is 0.48. So you go back to the beginning when you got your assignment back and you say, wow, I scored less than half. I scored less than 50%. Is this less than 50%? By a little bit, right? But it still is. Therefore, it makes sense. Yes? Not necessarily. But the place of the decimal is going to be extremely important. Number 9. Next page, 244. Find two ratios equal to each ratio. Raise your hand if you've ever put together equivalent fractions. Raise your hand if you understand why half is equal to 4/8, or 3/6, or 5/10, or 100/200. It's the same thing. I can make equivalent ratios the same way, either by using multiplication or division. What route do you want to take? I just need two equal ratios. So one here, one here. My options, multiplication or division. Chris, what do you want to do? What do you want to divide by? They have to both be divisible by what you say. 2. So 212 divided by 2 is 1, 0, and then 100 divided by 2 is 50. Good enough. Is it as simple as it could be? Does it have to be for this section? Okay, so we use division here. How about multiplication? Let's use multiplication here. We want to multiply both the top and the bottom values by. It has to be the same. 2? 212 times 2, Chris? 100 then times 2? 200. My choice. I can do both multiplication if I want. I could do both division if I want. It doesn't specify for numbers 9 through 11 or 12. You can pick with what you want. But the important thing is you need both. For example, number 10 is 36 to 18. I need 2. When the numbers are smaller, it might be really easy to use division. What are 36 and 18 both divisible by? 9. 36 divided by 9 is? 18 divided by 9 is 2. To get one more, can I get one more out of this? What? Using division? 2 over 1. Do I need both values? Do I need the 2 over the 1, or can I just call this 2? I need both values because it's a ratio and it compares two values, two quantities. So either of these would be okay, acceptable. 13 through 16, Write each ratio in simplest form. You got it right now. Or all of you, if it was like an improper fraction looking kind of ratio, you kept it as an improper fraction, did not convert it to a mixed number. Let's just make sure that we're accurate. 44 divided by 4, 12 divided by 4, 11 to 3. Very good. 18 to 8, both divisible by 2. Therefore, 9 to 4 looks good, right? Can't get any simpler than that. 16 to 56 looks like we went by 8, 2 to 7. Very good. And then 9 to 72 looks like we went by 9. 1 to 8 is the final. Very good. All 4 of those are correct. Anyone get all 4 of them correct in their work? Outstanding. Good. Okay. I've got your sheet for you. I want to hand out to you. Take a look at. Numbers 1 through 4, the directions tell you what? Three ways. So don't come back tomorrow and only have one way and say, oh, I didn't know we had to put all 3. It's right there. So number 1, 10 years ago in Louisiana, schools averaged 182 pupils for every 10 teachers. What's the ratio? Alex? 182 to 10? Yep. Followed by, it's got to be 3 ways. Alex? And then finally, Alex? Very good. That right there is going to give you full credit. Yes, Africa? 182 pupils for every 10. In fact, right, 182 to 10. It was the first one listed. Okay, so like number 2, in a recent year, 41 out of 250. Okay, so just read them carefully. They're going to throw in other numbers there to try to confuse you, throw you off. Try to find the ratio, try to sniff that out. Use the chart below for exercises 5 and 6. Okay, if you're working on 1 through 4, just stop for a second and look at 5 and 6. Everyone's pencil moved. Everyone's. The 7th grade classes were asked whether they wanted chicken or pasta served at their awards banquet. Okay, so if you look at the chart, room 201 was a ratio of 10 chicken to 12 pasta. Room 202, 8 chicken to 17 pasta, and room 203, 16 chicken to 10 pasta. So number 5, in room 201, what is the ratio of students who prefer chicken to those who prefer pasta? So if that's how they write it, chicken to pasta, those are the values you put in that order, chicken to pasta. So what is it for room 201? Chris, 10 to 12. Do you have to write it 3 ways? Does it say 3 ways? No. So you just pick one way, that's fine. Can you simplify it? You could. Would it be wrong if you simplified? No. So you have to. Does it say in simplest form? No, not yet. All right. Then 6, combine the totals for all 3 rooms. What is the ratio of the number of students who prefer pasta to the number of students who prefer chicken? Is it a different order than was just previously asked to you? Is it a different order? Yeah, because now they're saying pasta to chicken, not chicken to pasta. Okay, so be careful there. 7 through 14, write each ratio in simplest form. Okay? 15 is extra credit. Okay, so 1 through 14, 15, extra credit.